Hi, Math 30-2s. Welcome to the first lesson of our next chapter in this year or this term, having to do with logical reasoning and set theory. So today's lesson, a lot of terminology, okay? So you'll see a lot of bolded words, a lot of things we want to highlight and make little notes about in the columns or the sides of the notes. With these terms that we're going to learn today, we have to be very familiar with them as we move forward for the rest of the lesson when we start doing things like Venn diagrams, okay, and then as we move into probability, those types of things in the next couple of lessons. So please make sure if you have any questions about terms, what they mean, how we use them, that you get in touch with me and I can hopefully make it a little more clear for you as we are moving forward in the next couple of weeks. So just in the overview there, it says, in this unit, we'll explore the subject of set theory, the mathematical study of collections of objects. We'll be introduced to connecting words such as and, or, and not, and their counterparts in what we call set theory. We will work with Venn diagrams and use them to illustrate concepts in set theory. Things like empty sets, disjointed sets, subsets, and universal sets. Again, all those terms that you see in there that you're probably a little unfamiliar with right now, we will deal with them moving forward, but those are the key phrases and terms that we need to make sure that we understand. Okay, so first thing here are statements. In mathematics, we deal with what are called statements. A statement is a sentence that has truth value. Now, it is important that we say it is either true or false. Okay, it's not necessarily always true. A sentence that may be judged true by one person and false by another would not be a statement. That would be what we call an opinion. Okay, so we want to know the difference between an opinion and a statement. So consider the following. It says the city of Vancouver is in the province of British Columbia. This statement is true. Okay, it is a fact. Okay, there's no disputing that. The city of Vancouver is on the planet Mars. Again, this is a statement, but this time it is false, okay? It does not take into consideration anyone's opinion. Someone is making a statement, but this time it is false, and that goes with up here where we said statements can be either true or false. Next, it says Vancouver is the best place in the world to live. Now, this is not a statement because it is basically expressing someone's opinion, what they think is true or false. So again, not a statement, that is someone's opinion. And then finally, how do you get to Vancouver? Okay, well, obviously, even if you look at the punctuation, okay, the question mark at the end, not a statement. Okay, this is a question. Okay. Now, it says determine whether each of the following is a statement. For each statement, write its truth value. So the number 4 is a prime number. So again, the first thing that you want to make sure you understand is what a prime number is. Okay, so a prime number, again, if you remember or if you do not, okay, a prime number is only divisible by the number 1 and itself. Okay, so that is the definition of a prime number, okay? Or the only factors of a prime number are 1 and itself. So 4 being a prime number is the statement they make. Okay, well, that statement is false. Okay, it is a statement, but it's false. Okay, the reason being, if you take a look at the number 4, it is divisible by also 2, not only 1 and 4, but it is also divisible by 2. So it is not a prime number. Next, driving in a car is the best mode of transportation. Okay, this is not a statement. Okay, this would be something that we consider to be what? This is an opinion, okay? Somebody, they think that's the best way of traveling. And then the third one here, if you double an odd integer, okay, and again, please remember an integer is a positive or negative whole number. Okay, that's what an integer is. So if you double an odd integer, then you get an even integer. So again, you know, we can take any odd number that we want, okay, and if we double it, we will get an even number. So this is a statement, okay, it's a statement somebody's making, and this time it is true, okay, that is true. Okay, so again, hopefully statement, opinion, question, those things are clear in your mind. And again, any questions, just email me. Now, next page, the negation of a statement using the word not. So the negation of a statement, okay, so again, this is obviously a key phrase here. Negation of a statement is the opposite of a statement. The word not is often used to form the negation of a statement. For instance, one way to write the negation of a statement, the city of Vancouver is in the province of Alberta, is to write the city of Vancouver is not in the province of Alberta. Note that the original statement is false while the negation is true. Okay, so that leads us to a couple of important points here. In every case where the original statement, okay, is true, then the negation will be false. In every case where the original statement is false, okay, the negation will be true. Okay, so then the original statement and negation are always opposite. Okay, fake stop sign guy here. Okay, it would not be correct to say that the negation of the above statement is a statement like the city of Vancouver is in the province of Saskatchewan. Both this statement and the original statement are false. Okay, a negation must always have the opposite truth value to the original statement. Okay, so they do have to be opposites. Okay, a student made the following false statement: all triangles are isosceles. Okay, that's not true. They can be equilateral, they can be scalene. Which of the following statements below is the negation of the above statement? Is it all triangles are not isosceles, not all triangles are isosceles, or all triangles are scalene or equilateral? Okay, well, again, remember we use the word not. Okay, so the answer is going to be B. Not all triangles are isosceles. Okay, and there we go. Okay, write the negations of the following statements. It is 20 degrees outside. Okay, this is simply it is not 20 degrees outside. Okay, so there's the first one. It is not Saturday today. Well, that would be like saying it is not Saturday today, which is it is Saturday today. Okay. So again, opposites. Okay. So there's some examples and dealing with what we call the negation. Okay. Next important term, okay, is a compound statement. So a compound statement is formed by combining two or more statements. So I take two or more statements and I bring them together, and that's what gives me what we call a compound statement. The words and or are often used to form compound statements. So for example, it is 20 degrees outside and it is not Saturday today. It is 20 degrees outside or it is not Saturday today. Okay, those are both examples of compound statements. Again, taking two or more statements and bringing them together into one. That's what we call a compound statement. So forming a compound statement using the word and. The conjunction, okay, so again, another important term. The conjunction of two statements can be formed by using the word and. A conjunction is true only if both the original statements are true and it is false otherwise, okay? So, for example, the conjunction of blue is a color with ice is a solid is the statement blue is a color and ice is a solid, okay? It is true because both original statements are true. The conjunction wet is a color with ice is a solid is the statement wet is a color and ice is a solid. It is false because one of the original statements is false. Next example, the conjunction of wet is a color with ice is a liquid is the statement wet is a color and ice is a liquid. It is false because at least one of the original statements is false. And in this case, both are actually false. So in order for a conjunction to be true, both portions have to be true. If one or both are false, okay, then it is false in itself. So next, using or forming a compound statement using the word or. In everyday English, we use the word or in two different ways. Okay, the following examples illustrate the important differences. So in everyday English, this is how we use or. In order for Andrew to have the necessary prerequisites to go to college next term, he needs to pass or a pass in grade 12 physics or a pass in grade 12 chemistry. This statement means that he will have the prerequisites if he passes just grade 12 physics, or he passes just the chemistry, or if he passes both. Okay, if any of those three scenarios occur, okay, he passes. This is what we call the inclusive use of or in everyday language. Next example, John asked Helen how she will be getting to school tomorrow. She replied, I will take the bus, or I will drive myself. This means Helen either takes a bus or she drives herself, but she cannot do both. Okay, this is an example of the exclusive use of the word or. So one or the other, but both are not basically possible. So when we use the word or in mathematics, as it says here, in mathematics, including in set theory, when we use the word or, we always mean the inclusive version of or. Okay, so that is one scenario or the other scenario, or both can happen. Now, the disjunction, okay, of two statements is formed by placing the word or between them. A disjunction is only false if both statements are false. A disjunction is true if any of the following happens. The first statement is true, the second statement is true, or both statements are true. Okay, and again, all of these we will see in examples moving forward. But again, I want you to circle or highlight all the things that I am so that when you go back in your notes or you're referring to an example, you know the key points that we need to make sure we understand and focus on, okay, as we move forward. So it says, consider the following statement. Ivan rolled a pair of dice and the sum of the two numbers was an odd number or a prime number. Okay, so in that scenario, because we've used the word or, okay, it can be one characteristic, the other characteristic, or it could be both. So it means that the sum was an odd number or a prime number, or it could be an odd number and a prime number. Again, this is an example of what we call the inclusive use of or in mathematics. Okay, it could be one or the other or both. Okay, so here, consider the natural numbers x that are less than or equal to 15. List the numbers that satisfy each of the following conditions. So again, one for our part A, it just says x is an odd number. So if I'm talking about natural numbers, okay, my odd numbers that are less than or equal to 15 would be 1, 3, 5, 7, 9, 11, 13, 15. Okay, those are the odd numbers that are natural. Next is x is going to be prime. So again, prime numbers, the only factors they have are 1 in themselves. So the tricky one there is 2. Okay, people always think that 2 is not prime because it's even, but if you think about the factors of 2, it's only 1 and 2, so 1 in itself. So 2 is a prime number. Next, 3, 5, 7, 11, and 13. Okay, so all of those numbers, they only have 2 factors, 1 in itself. Now, a number a lot of people think is missing from that prime list is the number 1. The number 1 is neither prime nor composite. So maybe on the side here, that's a good note to make. Okay, neither prime nor composite. So composite, again, is the opposite of prime. Okay. All right, C, x is odd and x is prime. So when we use the word and, it has to be both. So you basically cross-reference your 2 lists that you just were talking about there. So that's 3, 5, 7, 11, and 13. Okay. All right, x is odd or x is prime. So again, that means it can belong to one list or the other list, or it can belong to both. So basically, it's the combination of those 2 lists. Now, you don't have to repeat the numbers, but as long as it belongs to one of those lists, it should occur in this solution. So it would be 1, 2, 3, 5, 7, 9, 11, 13, and 15. Okay. Next, x is a factor of 3 or 5 or 7. So it doesn't have to be a factor of all of them. It only has to be a factor of one of them. So for example, 1 is a factor of all of them. 3, well, that's a factor of 3. 5 is a factor of 5, and 7 is a factor of 7. So any of those numbers in that list are a factor of 3 or 5 or 7. Okay. Next, x is a factor of 3 and 5 and 7. So it has to be a factor of all of them. So the only number that is a factor of all of them, okay, is the number 1. All right. Next, x is a multiple of 3 or 5 or 7. Now multiples again are basically counting by that number. So the multiples of 3 would be 3, 6, 9, 12, 15, etc. The multiples of 5 would be 5, 10, 15, 20, etc. And for 7, the multiples would be 7, 14, 21, 28, 35, okay, etc. So if it's a multiple of any of those numbers and we're using the word or, it just has to be a multiple of any of those numbers. So it's going to be quite a long list, right? 3, 5, 6, 7, 9, 10, 12, 14, and 15. Okay, so again, any of those numbers I just wrote down are multiples of any of those numbers, either of them, okay, the 3 or the 5 or the 7. And then finally here, x is a multiple of 3 and 5 and 7. So it has to be a multiple of all of them. But again, natural numbers less than 15 because that's the original instructions. So if you take a look at the list that we have, there are actually none. Okay, no numbers that are multiples of all three of those. So that's it. That's the lesson. Okay, so again, make sure you're somewhat comfortable with the terminology, the difference between the word and or, all the different kinds of statements, how we negate them. And so a nice short lesson to start this chapter today, you guys.